Title your notes, Applying Systems Part 4. Part 4. Today we're going to finish up with systems of equations, and then we're going to move on tomorrow with inequalities. So, our objective for today, I can solve real-world problems using systems of linear equations. Read together. 1, 2, 3. One more time. 1, 2, 3. What concept are we on? So you know the definition of system of linear equations. That is correct. Two or more linear equations with the same variable. Very good. So we don't need a Freire model. By now we know these by heart, just in case you get definitions in the parte, right? I mean in the cumulative parte. So you should know all this, yes? Definition, examples, non-examples, hashtags. What acronym are we still using for word problems? Cube, circle important numbers, underline the question, box important terms or ideas, exclude unnecessary information, and draw pictures, diagrams, tables, labels, etc. Okay? From there, we started with the first type. Is everybody familiar and comfortable with the first type of word problem? Item and cost. Remember those? We started with this one with sheets of cardstock and felt. From there, we went to a flower problem, same thing with a cost, and so on and so forth. From there, we moved on to a funner one, which was a rate problem in regards to rate and distance involving an airplane and boats and stuff like that. From there, we moved on to a mixture problem, which is probably your favorite one. And we did some of these, left you some for home play also. And from there, we move on to this new one. Copy this one, please. Example 8. Example 8. It is. Okay, thank you. Read that for us, please, Diego. Hold on, I can't hear Diego. Example 8. Go ahead. Very good. So copy that problem, then we're going to go over this one together. You got 1 minute? Go. All right. I'm going to cube this one. Let's do this one together. Cubed. So let's circle in blue important numbers. Important numbers, it says here, two-digit, the digits of two-digit number is 10. Okay. 54 more than the original number. Okay. Underline the question. What is the original number? Okay. From there, box important information. Important information is that they're talking about the sum of the digits. Sum of the digits of what? Of a two-digit number. Okay? But then they say, what's important here? That the digits are what? Reversed. The digits are reversed. And then they say that it's a what? New number once it's reversed. Okay? Exclude any other information, and then we're going to draw a table. Before I draw a table, let me give you the scenario so you can understand what they're talking about. It says here, the sum of the digits of a two-digit number. So I'm going to write a number, not related to this problem. Tell you never what I just said. All right, so I'm going to write a two-digit number. I'm going to say, okay, 57. Okay, is that a two-digit number? Yes, because it's got 1, 2 digits. Okay, but if I use this format and it says the sum of the digits, what do I need to do to these two? So then the sum of the digits of this one is 12. Then it says the digits are reversed. Okay. Therefore, the new number has to be so much more than the second. So let's see. What is, oh, my bad. I'm doing the sum for the second part, and it's not a sum. This is the new number. So check this out. From here. So 75 take away 57. How much more do we have on 75? So let me do that here. 75, 57. That is 6, 15, 8. Yes? And then 1. So then the new number is 18 more than the original number. Let's see. 57 plus 18, 5, 7 is a new number 75? Yes. Okay, we're using it today, as a matter of fact. Yeah, in real life, you're going to go home and do this. So that's what's going to happen to this number that they're giving us. So here goes the process. This is a word problem, yes? So what do we do with word problems? We start a table. How many lines down? 3. So 3 lines down. 1, 2, 3. 2 across. All right. So they're talking about 2 digits. What kind of digits are we talking about? Very good. Tens and units. Or you guys can call them ones, right? And here's the total. So I'm going to start with the first row with my original number. So I'm going to put original. Original number. It says the sum of the 2 digits of a 2-digit number is 10. So do we know the 10th digit of the original number? Do we know the number? No, we don't. So what would we label the 10th digit? Well, in this case, I'm going to use the letter T. And then, do we know the units? No. So what would we label it? U. But the sum of these is equal to what? 10. So the total is what? 10. Everybody understanding? So now let me show you the equation so far, the original. T plus U equals 10, because it says the sum of the digits of a 2-digit number is 10. 10's digit plus units equals 10. Are we there so far? All right. But then it says the new number is the one that you reverse the digits. So let's put new number. So what do I write here? It says reverse the digits. What do I write here? U is correct. But now that we wrote the U here in the 10th spot, it can't be just U. It's a what? 10U. 10U. And the T goes here because the digits were reversed. Once the digits are reversed, it says the new number is, that means equal, is what? 54 more than the original. What was the original? T plus U, right? So T plus U, but 54 more is plus 54. Did everybody understand where I got that from? It says the new number is 54 more than the original. The original we said is T plus U, yes? 54 more is plus 54. However, this looks kind of funky with a 10 on the 10th digit. So that the entire equation is in same terms, I'm going to put 10 also for the 10th digit of this one. Now let's write our equation. 10U plus T equals 10T plus U plus 54. Okay? So you're like, Mr. Q, this looks a little confusing. Well, let's simplify it. Let's simplify this blue one. Line down the equal sign. I need to get the T and the U together, right? So here I subtract 10T, subtract 10T. But let's subtract also the U. Subtract U, subtract U. This cancels. Bring down the 54. So let's see, what do we have? And I'm going to write the t first because that's the tens digit, right? So what is negative 10t plus t? Negative 9t. What is 10u minus u? Plus 9u. Are we there so far? So now this looks a little bit more familiar like the first one. Is that correct? You're like, yes, Mr. Q. So I'm going to bring this one down over here. T plus u equals 9. So now we have a system that is a little bit more doable. So question, what method do you want to use to solve? Elimination. So therefore, which one do you want to eliminate? The t or the u? Oh, this one was 10. Sorry. Equals 10. Yes. No, I know. All I did is I placed them in order. This one, I finally moved it to the 10 spot. This one, I moved it to the U spot. You see it? Yes? Okay. So let's eliminate the t. So if we're going to eliminate the t, what do I need to multiply this entire equation by? 9. So distribute, that's 9t plus 9u equals 9b. So now I'm going to focus on this one and this one. What can we do now? Eliminate. What eliminates? The 9t. This one and this one. So we're left with, what is 9u plus 9u? 18u. What is 54 plus 90? 144. That's all for you. Divide by 18. Divide by 18. U equals, do the division. 144 divided by 18. I'll wait for you guys. 8. Thank you, J-Lo. So now that we have 8, we need to figure out what t is. Is that correct? So what is my original? T plus u equals 10. But instead of u, we're going to write 8. So we got t plus 8 equals 10 minus 8 minus 8. T equals u. 2. So this is the 10th digit. This is the unit. So what is my original number? 28. So let's write that. The original number is 28, and the new number is 82. 10Q. Let's check to see if it's true. Our original was 28. And then it says here that the new number is 54 more than the original. That means we need to add how much? 54. Let's see. 12. We got 1. 7 plus 1, 8. Is our new number 82? Yes. Pretty good, huh? Yes. In life? Today? You're getting... Okay. One question. Let me answer this question. Now, there's some problems that totally, completely apply to stuff you're going to do in the future. But most of the algebra that you learn, it's not only to help you with what you're going to do in the future, but it's to help your noodle reason. Part of the process of you learning how to reason with numbers and abstract values, which is the missing number. Now, you're like, what are you talking about, Mr. Q? Yeah, you started off in elementary. They used to tell you, what's the missing number if we add 3 plus a number? What would be our new number? Or they give you the new number, let's say 7. 3 plus what number equals 7? So then you say 4. Okay, so the missing number that you learned in elementary, now we label it as a variable, yes? So in order for you to learn how to get to algebra, you need to learn the missing value, yes? So it's all part of a process of reasoning. So now, are all of you going into mathematics and engineering? No. There's only a fraction of you that are. Those of you that are going to use this. Those of you that are not going to use it. However, let me tell you what's going on. Some of you that do not like mathematics and that you're going into teaching, I really suggest you learn more math, because we do need teachers that are prepared in mathematics. Because there are some teachers that are not prepared, and therefore when some are going through elementary, and if you are not being prepared adequately by the time you get to middle school and high school, some of you are missing a lot of stuff, which is the reasoning part. So to answer the question, Mr. Q, when are we going to use the digit number in real life? Probably never. But does it help you reason? Yes. Hopefully. Copy this one. Example 9. See if you can do this one by yourself. Yeah, just process. Yeah. Okay, copy the problem. Everybody, thank you, Megan. Yay! For Presidente. So example number 9. The sum of the digits of a 2-digit number is 5. When the digits are reversed, the new number is 9, more than the original. What is the original number? Hold on. Copy that and solve it by yourself. Don't give me the answer now. Yes, question. For right now, they're just going to be reversed. Yeah. Ready, go. All right, so you already cubed it. I'm going to start from the table. Here we go. 3 lines down. 1, 2, 3. 2 across. 1, 2. Nice and straight like mine. We got tens, units, total. Here's the original. Is T, U, and 5. The new number is 10U, T, 10T plus U plus 9. Hands if you got that by yourself. Okay, good. So I'm going to write my first equation as T plus U equals 5. And my second equation, look what I'm going to do. Well, yeah, I'm going to write it so you can see the entire process. 10U plus T equals 10T plus U plus 9. I'm going to simplify the second equation. Minus 10T and minus U. We're left with 9 equals, and then I'm going to write the T first, so this is negative 9T. Then the U over here, that's 10 minus 1, that's 9U. Okay. So I bring down my original. What? Okay, it's in the 10th spot. The 10th digit. So, focus please. We got t plus u equals 5. So now we're going to eliminate the t, so we multiply the entire equation times 9. We get 9t plus 9u equals 45. Eliminate, we're left with 18u equals 54. Thank you, Joseph. $54 divided by 18 is 3. Okay. Then we use our original t plus u equals 5. Minus 3. T equals 2. So the original number is 23 and the new number is 32. 10 here. And did you got that? Okay, good. We did use the 5 for the original. Yes. Why would it be 5? Okay. Okay, let's do one more. We're not going to copy the problem, but let's do the setup. Here we go. Number 10. Write example 10 and then draw the table. 1, 2, 3. 1, 2. Label these. This is what? 10 units total. Here's the original. Tell me what you write for the original number, please. T, U, 11. Okay. New number. Joseph. Yeah, go. 10U, that is correct. And then? That is correct.
Dude, I don't get this right then.
Because it says the digits are reversed. If the original digits are T and U, when you reverse them, what is it? U and T.
Where did you get the 10 from?
Well, now that the U is in the 10th spot, we can't label it U because it would be units. But now it's in the 10th spot, so it's how many units? 10 units. Every single time. Oh, for the sum. Yeah. Oh, okay, got it. Yeah, well, it doesn't go like that. All right, here we go. So what else do I write? Italiano, go. $10T plus U. That is correct. So let's write our equations. T plus U equals 11. The second one is 10U plus T equals 10T plus U plus 45. So now let's simplify the second one. Minus 10T minus 10T minus U. Bring down the 45. So this is, okay, so be nice. So I'm going to start with a T and I'm going to put it on the 10th spot. So what is negative 10T plus T? Negative 9T. Everybody see what I did?
No.
And then 10u minus u, that's positive 9u. And now we bring down the original. T plus u equals 11. And now we're going to eliminate t, so we multiply times what? 9. So there's 9t plus 9u equals 99. So therefore, these cancel. We're left with 18u equals 144. Is that correct? Divide by 18. U equals 8. Yes? So t plus u equals 11. T plus 8 equals 11 minus 8. T equals 3. So my original number is 38, and my new number is what? 83. Get your home plate over here. Make sure you get the Saturday Academy sign, and the flip side done. There is home plate tonight. It's a play sheet. And there is tutoring today. If I don't see you, have a good one. See you guys tomorrow. Bye.